Okay, so today we're going to do chapter 5, continuous random variables. And let's start with some of the properties. The probability, we're going to be talking about the area under the curve, okay? The graph is a curve, and we're going to talk about the area under it. Area under the curve is given by CDF. We've already talked about CDF and PDF. CDF is the area to the left, and we've already talked about that. The outcomes are measured, not counted. The entire area under the curve and above the x-axis is equal to 1. All the probability equals 1. Probability is found for intervals of x value rather than for individual values. Okay, so we're not just finding an x value like we've done in the past. We're finding intervals. And this next piece is talking about that. The probability that x is between C and D. Okay? The probability that x equals C is 0. That means that the probability that x takes on any single individual value is 0. See, x equals C. That could be any value equals 0. Again, we're not finding individual x values in this section. We're finding intervals. The area below the curve, above the x-axis, and between C and D has no width, therefore no area. Since the probability is equal to the area, the probability is also 0. That's when x equals C, just one number. This also is important. The probability that x is between C and D is the same as this, okay? Because we're talking about area. The uniform distribution. So before we did the binomial, so if x is a binomial, and remember binomial is simply yes or no, there's only two choices. The binomial we did like this. Now we are going to do uniform distribution, and we're going to use A and B, and you'll see where the A and B come from here in a minute. So the shaded area represents the probability that x is between 3 and 6. So here's your curve. All this equals 100, right? And we're looking at just the shaded between 3 and 6, okay? All right, so normal distribution. That's the example. There's the curve. All the area underneath it equals 100%, equals 1. All right, so here we start, 5-1. Okay, so continuous probability. Probability equals the area. Consider the graph f of x equals 1 over 20. Now remember that this simply is y equals 120, right? 1 over 20. For any x between 0 and 20, x equals a real number. The graph of y equals 1 over 20 is a horizontal line, and we see that right here. Remember, y is the lazy line. It looks like that. However, since x has to be from 0 to 20, y is restricted to this portion in here. Inclusive. So that's our parameters. X can be anywhere between 0 and 20, and y equals 1 over 20, okay? So if we want to find the area, okay, between f of x equals 1 over 20 and 0 to 2, we simply do area of a rectangle, length times width, okay? So here's the area 2, and this looks a little different because it extended the y line out to 20 instead of just, but we're just looking at 0 to 2, okay? So area equals, the length of it is 2, and the width is 1 over 20, so that gives us 0.1. So the probability that x is between 0 and 2 is 0.1, which can be written as the probability, oops, not that way, that x is between 0 and 2 equals the probability that x is less than 2, right? Same thing because of that 0, which would equal 0.1. All right, so we're going to do another one. I didn't mean to turn the page. It's right over here. Oh. So here's the same thing. Area equals length, which is 11, okay? Between 15 and 4 is 11. So that line, that is 11. This is 1 over 20. So 11 times 1 over 20 equals 0.55. So the probability, I always want to, did it again, that x is between 4 and 15 is a little over half, 0.55. Okay? Suppose we want to find the probability that x equals 15. 15, let me write this differently. X equals 15 is a vertical line, right? All right, so x equals 15 is a vertical line right here. So when we do the probability that x equals 15, we get the width is 0 times the height, which is 0. That's why up here we said, whoops, it's on the other page, that the probability that x equals any number equals 0, because there is no width to it. And we're looking at area. We got to have width. Okay. Oops. One more. Find the probability for f of x equals 120. All right, so we are going to look at the probability that x is between 2.3 and 12.7. And we get, what's the width there? The width is 10.5 right here. 0.4, sorry. And the height, I don't want to do it on that side though. I'll do it over here. Is 1 over 20. Now while I'm doing this, if you've got questions, please make a mark so you can ask me on Wednesday. Now it says consider the function f of x equals 1/8 for 0 to 8. Draw the graph. So if I draw the graph, my y line is here, y equals 1/8. So that's what this is. And then 0 to 8. So the probability that x is between 0 and 8. Whoops. Oh, no. Let's mess that up. It's between 2.5 and 1.5 that we were doing the probability for. So the probability is between 2.5 and 7.5. This is what we want the probability for. So 2.5 and 7.5. The distance between them is 5 times the width, which is 1/8, equals 5/8, which is 0.625. Okay, so now we're doing 5.2. The uniform distribution, we're going to look at it specifically. So continuous probability distribution is concerned with the events that are equally likely to occur. Now, it says, be careful to note on these whether it is inclusive or exclusive, okay? So, here we have the probability density function is f of x equals 1 over BA. So let's write it. F of x equals 1 over B minus A. Okay. For A, x being between A and B. Formulas for the theoretical mean and standard deviation are given below. So here is our distribution that I already showed you. That's where that A and that B come from. A is the lowest and B is the highest value of x. Okay. You also think of it as D minus C. And these two are on your formula sheet. Okay, but mean, that's just average, right? You add the lowest plus the highest, divide by 2. That gives you the average. Makes sense. This should be number of events that are taking place. Okay, so no, it doesn't. This is always This is always 12. Okay, and that comes from the calculations on in calculus. Why? This is okay. The 12 is because of the squared deviations from the mean that are distributed. It's a predictable way, leading to a factor of 12 in the calculation. And so that always stays 12. Sorry, I thought it was a misprint until I remember what we were doing. So, data in the table are 55 smiling times of an 8-week-old baby. So, your paper doesn't have this. We're going to find that. So let x equal length of smile. Okay, and so this is a uniform distribution where A is the lowest and B is the highest. F of X equals 1 over B minus A. So F of X, let's see, and let's write this. Where A is lowest and B is highest. All right, so F of X is 1 over the highest. B is 23. And the lowest B is 0. So I get 1 over 23. So the theoretical mean and standard deviation, the mean is A plus B divided by 2, which is 11.5. And standard deviation is 23 minus 0. I'm just using those formulas over here on the sheet before, right there. Okay, and so the standard deviation is 6.64. So you can expect the smiling times to deviate 6.64 from the mean of 11.5, right? And it'll still be normal. All right, try it. This is the number of passengers on 35 different charter fishing boats. The sample mean is 7.9. And the sample standard deviation is 4.33. The data that follow a uniform distribution okay, and if I look, that would be, A would be the lowest, would be 0, and the highest would be 14. The data follow uniform distribution is 0, including 0 and 14, equally likely. State the values of A and B. So there's our A and there's our B. Write the distribution in proper notation, which is, that's also right, this right here. Okay. And calculate the theoretical mean. So the theoretical mean equals A plus B divided by 2 equals 7. The theoretical standard deviation is, this is for a sample, so I feel better using S other than that sigma. So 14 minus 0 squared over 12 equals 4.04. And that's our theoretical mean and standard deviation. So what's the probability that a randomly chosen 8-week-old baby smiles between 2 and 8 seconds? So remember, we have a uniform distribution of 0. Let's see, what was that? Smiles was 23, right? On the other page. All right, so that's our distribution. We want the probability that X falls between 2 and 18. okay? So we've got 16, 18, the length there, between 2 and 18 is 16, and our y value is 1 over 23 equals 16 over 23. Okay? Now, where you might want to know, might wonder where I got the 1 over 23. Remember, f of x, or my y, equals 1 over b minus a. So in this case, it'd be 1 over 23 minus 0, which is where I get my y value. Okay? And so if you think about that box that we're finding, the area, that would be my length or height, whatever you want to say, and my width was between 2 and 18. My width is 16. Okay? So now it wants the probability of the 90th percentile. So what we want to know is what value gives us the percentage of 90%. So if we think about this, I know that my base times height, right? Length times width, whatever it is you want to call it, equals 90%. All right, I know my height is 1 over 23. And my base, okay, that's not B is up there, it's B is my base, would be a number minus 0. And so then I'm just going to solve it. Multiply each side by 23. And I get K equals 20.7, okay? So the 90th percentile would be 20.7 seconds, okay? Find the probability that a random 8-week-old baby smiles more than 12 seconds, knowing that the baby smiles more than 8 seconds. So find the probability that x is greater than 12 given x is greater than 8. Okay, so let's actually draw that out on our next slide. I actually have this slide, okay? And I'm going to rewrite that. We're looking for the probability that x is greater than 12 given, okay, that it's greater than 8. So now we've been looking at up here 2 to 8. Oh, well, no, that's not the same. Okay, so we've been looking at those 0 to 23. All right, so now given that it's greater than 8. So given that we know the baby smiles more than 8 seconds is that area right there, right? What's the probability that the baby smiles more than 12? So I am going to do 23 minus 12, because that gives me this area. 23 minus 12 is 11. times the height, 1 over 15. So 11 times 1 over 15 equals 0.73. So all that means is I know that I've eliminated all of this over here, okay? I know that baby smiles more than 8 seconds. So there's a 73% chance that if a baby smiles more than 8 seconds, that baby will smile more than 12 seconds. We can also do it, write it out like we had, the probability of A given B, okay? So equals the probability of A and B all over the probability of B. So if we write out the probability of A and B, we would have X is greater than 12 and X is greater than 8 all over the probability that X is greater than 8. All right, so the probability that X is greater than 12 and X is greater than 8. It's got to be both. So that would just be from here to here. 12 to 23 is 11 out of 23. All over the probability of B. Or X is greater than 8. So X is greater than 8 is this. 8 to 23 is 15. So then, if I do that, I get 11 over 15, which is 0.73. So exactly the same 11 over 15 that I got here. Okay? All right, so I think I want to do one more, and then we'll call it a day till I get here. So, example 5.4. We know we're dealing with a uniform distribution. Lowest value is 0, highest value is 15. And it tells us uniformly distributed between 0 and 15 minutes inclusive. What's the probability that a person waits fewer than 12.5 minutes? So the probability that X is less than 12.5 equals length times width. On average, find the mean. Okay, that's what it's asking. On average, how long must a person wait? On average, that's the mean. So the mean is A plus B divided by 2. And the standard deviation. Standard deviation is A minus B squared over 12. And I don't actually have that answer written down, so you can put it in your calculator. And then it says 90% of the time a person must wait below what value? Okay, so the probability that X is below what number equals 90%. That's what we're finding, okay? So that means that K minus 0, right? Or just K, really, times 1 over 15 has to equal 90%. So K equals 0.9 times 15, which is 13.5. That should get you really started on the homework, so you can work on that then. And I will do the rest of these in class with 6-1 tomorrow.